in this video, I want to explore a more concrete example of the sum of an infinite geometric series, like we derived in previous videos. We know from a previous video that if we have a number a, like maybe a is 2, and we have a number not b, but r is what we typically call it. R is, say, 1/3. If we have a is 2 and r is 1/3, then the geometric series is the sum starting at 0, going up to infinity, of a times r to the power of k. And for our specific values, we could expand this out, and we would get a times, well, k starts at 0, r to 0 is 0, so, r to 0 is 1, so we just get a, plus a again, but now r to the 1 is just r, plus ar squared, plus ar cubed, on and on and on. And we figured out that this value here, this infinite sum, is equivalent to a divided by 1 minus r. That this infinite summation is equivalent to this formula here, under the condition that r was greater than -1 and less than 1. This is our caveat here, because if r is less than -1, this series will oscillate and diverge, and if we graphed it, it would oscillate and diverge up and down. And if it was greater than 1, it would just do this, going off to infinity, never returning. And in this video, I want to get a concrete example of what one of these series could look like. So I think a perfectly fine place to start is with a equals 2 and r equals 1/3. A equals 2, r equals 1/3. Let's try this out. First, let's expand out our series here. Well, we know we're going to have a is 2, plus ar is 2 times 1/3 is 2/3, plus ar squared is 2 divided by 3 squared, plus 2 divided by 3 cubed, and this series will continue on an infinite amount more terms. And just to make this a little bit easier on us, we can factor this 2 out and get 2 times 1/3, 2 times 1, 2 times 1 plus 1/3, plus 1 divided by 3 squared, plus 1 divided by 3 cubed, on and on and on. And we've just taken the 2 out. And if we were to call this series S, let's get some colors in here. Let's call this series S equals 2 times 1 plus 1/3 plus 1 over 3 squared plus 1 over 3 cubed, on and on to infinity. If we call this series S, then we can multiply S. We could multiply S by what our R was, which was 1/3, and we can get 1/3 times S equals, we keep the 2 here, but now everything is shifted over, so I'm just going to pad our series with 1, 0, and then this 1 here is going to come down and going to become 1 times, well, the 1/3 is 1/3, and then this 1/3 is going to come down and be 1 over 3 times 3 is 3 squared, plus this 1 over 3 squared, I probably see the pattern by now, 3 squared times 3 is 3 cubed, and we're just shifting all of our terms along by 1. The multiplication by 1/3 in this case was equivalent to a shift. So when we come along and we say, let's try to subtract these from each other, we say, okay, let's go term by term. At the very start, we're going to get S minus 1/3 S, S minus 1/3 S, equals, well, let's just keep the 2 factored out. equals, well, 1 minus 0 is 1. And then this 1/3 here, this cancels out, plus 0. This 1 over 3 squared cancels out, plus 0. And all of these terms, off to infinity, these will all cancel out. So we will be left with, well, s minus 1/3 s is 2/3 of s equals 2 times 1, which is just 2. And if we do our multiplication here, the 2's cancel out, and we get that s equals 3. And this hopefully makes the whole process of multiplying by a constant to shift our whole series down. Hopefully this makes that a little bit clearer with a concrete example in mind.